Hey guys, video cut off just as I anticipated. This actually might need a third video, one more after this one, so if it cuts off, just click part 3. So continuing, we now have angle, side, angle, and you may notice that our last one was angle, angle, side. This is basically the same thing, right? You just, we are just now saying that we have this angle, congruent, a side, congruent, and this angle, congruent. And last time we said that the side was either here or here, but now we're saying it's here. Really, for this one, it doesn't. Oh my bad. I'm sorry. The other side. For this one, it doesn't really matter because it follows the same logic. Triangle has 180 degrees. Two of the triangles are two of the sides angles. Sorry, are congruent. This angle has to be congruent. We come to the same conclusion. One side guarantees that the rest of the sides are congruent, making our triangle congruent. But I do want to emphasize that this deviation here makes a difference. Basically, when the Greeks were coming up with these, what you have to ask yourself is there any possible other triangle that could be created with these specific angles and these specific lines that is not congruent? That's what you have to ask yourself when you're trying to prove these triangles congruent. And these here, write them out for you: side, 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 angle, side, are the 4 ones that guarantee it. Yeah, alright, so with that said, we have now done these 3. And this is the one that tricks everyone. Well, not really, but yeah. If we write this as side, side, angle, I want to start there. This does not work, even though it has the same specification, side, angle, and a side. It makes the difference. And I will show you why. If you have a triangle with an angle, let's say that this, with an angle, okay? Your angle. You have this side and this length here. This length here. If you notice, there's one more triangle possible, being this triangle there. Same side length, but different angle. You see, the problem here is this specific angle, the location of the angle that you're specifying. Now, if we do this side, angle, side, it's a different story. Side, angle, side. Let's call this side equal, this angle equal, this side, and this side equal. Now, the thing with this one is that we have 2 sides, correct? And we know that the angle and a side have a specific relationship. As the angle grows, the side grows. as the angle gets smaller, the side gets smaller. We know these two for a fact to be equal. So then these, okay, let me explain like this. When we had the triangle, if you watched the first video, if not, I would recommend going back to that one. We drew our triangle, and we had our angle, and this angle, and this angle. We drew this one, and made this one, whenever it does meet the other line, really small. Okay, so if you notice, this angle got really small, but this side length stayed the same for both the triangles. And now the question you should be asking is, you're contradicting yourself now, and really we're not. I'll show you why. These two sides and these two sides are equal. This side, this angle, and this angle are equal. So what we're saying is that this will not change and this will not change. This side here and this length here have a definite relationship. This one and this one have definite relationship. This one and this one. Meaning these sides will not change. These angles correspondingly cannot change then, because this one is defined. So that might be a little confusing. So let's go back to this example, the side-side angle. Side-side angle. Side-side angle. Okay? The problem with this one is that the relationship between this angle and this side is completely unknown. You see, in this example, every side was corresponding